A compound inequality is where you take two inequalities and put them together. Okay? So that's what a compound inequality is. And there's two different ways we can put these together. So several inequalities can be combined together to form what is called a compound inequality. Okay? It just means you have more than one. So before we were just dealing with one at a time, right? X is greater than, or X is less than, or X is greater than or equal to, or less than or equal to. So the first type of compound inequality is an OR. Is an OR statement or an OR inequality. Okay?
What is that?
The first type of compound
inequality is
That blank,
and
OR.
O.
the capital OR,
OR.
right? Oh, my laser isn't working. There it is. No. Anyway.
Or.
This word right here, OR. At the point with my finger, it's like a primitive. All right.
Manure.
Is an OR inequality. Now, if you think about the word OR, it almost means exactly what we say in normal language. So if I say that after school today, before I came to class, so I'll just say, before I came to class, if I told you guys this, let's say it this way. After school, if I told you this, we'll say after class. After class, I'm going to go home, or I'm going to go to Sonic. Now that means if I go home and after class, if I go to Sonic, is that a true statement?
True.
Yeah.
Yeah. After class, if I go home, is that a true statement?
Yeah.
Yeah. After class, if I just decide to stay here, was my statement true?
No.
No. Now, the one thing that's a little bit different in English language as opposed to math language is if I go to Sonic and then also go home, in math language, that's still true. In our language, when we talk, we think of either or, not possibly both. So in math language, for this type of inequality, we want a true statement from either one inequality or the other inequality, or possibly both. Okay? So in order for our statement to be true, at least one of the parts has to be true. Okay? So that's what we're looking for. At least one of the parts has to be true for an OR statement to be true. Okay? If there are two different parts to the graph, then we will put a union. This is this like big U is a union symbol between our two sets of interval notation. And you'll see that as we go through these examples. Okay? And I think on the notes, did I put the other one there right away? No, I guess I did. Okay. So let's take a look here. Notice we've got this word OR in between the two statements. Right? You see how there are two separate inequalities? Okay. All we do is solve each one by itself. So I'm just going to start with this one on the left, and we're going to solve this one. And then when we're done, we'll go and solve the one on the right. So what do we have to do first? Because again, we're trying to get this x by itself. What do we have to do first?
Add 5.
Add 5.
3 plus 5.
So
And it doesn't
2x
change.
and 8. Do we have to change the inequality sign?
No.
No, because we're adding. So greater than. Then what else do we need to do?
Divide by 2.
Divide by 2. So x and 4. Do we have to change the inequality sign?
No.
No, because why?
There's not a negative.
Positive.
We're dividing by a positive, not a negative. So we're okay there. So x is greater than 4. Or now we go to the other one. And again, we're trying to get this x by itself. What do we, and again, you have to be careful with these, but what do we do first?
Subtract 4.
Subtract 4. That is a positive 4, right? So we got to subtract 4. Cancel that. We have the negative stays with the x. When we subtract 4, do we have to change the inequality sign?
No.
No.
No. So still greater than or equal to. Then what else do we have to do?
Divide by 1.
Divide by a
Negative
1. So that's x, and that's negative 2. Do we have to change the inequality sign?
Yes.
Yes.
Yes, because why?
You divide by the
We are dividing by a negative. This step right here makes us change the inequality sign. So this is now less than or equal to negative 2.
Okay.
Okay, now we're going to draw this on a graph, both of them. and make sure it makes sense. What are the two boundaries we are dealing with here?
4.
4 and
Negative
-2. Now, if you think about a number line, which one goes where?
4 goes in the right.
Yeah, 4 is over here. So even though when we did them, the -2 is over here in the 4, make sure you put them where they make sense on a number line. So let's do the 4. X is greater than 4. What type of circle goes on the 4?
Empty circle.
Open circle, yep. And then which direction does this go from the 4? Yep.
To the right.
Okay. Now, what about the boundary circle on the -2?
Closed circle.
Closed circle, right? And then you're right, it's going to go to the left. So closed circle, and it goes to the left. Okay? So in other words, anything in this area makes this a true statement. Anything in this area makes this a true statement because this is an or statement. As long as one of them is true, we're good. The only area that does not work is the middle between -2 and 4. So now we want to write our answer in interval notation. So we've graphed it. This is graphing the solution right here. We want to write this in interval notation. So let's start with this side. How do we write this one?
-2.
-2 is our boundary
Infinity on the left.
on the left. So what do we write?
Negative
-infinity, correct. Okay. And infinities always get
Parentheses.
parentheses.
Parentheses
What
and
will the
bracket.
-2 get?
Bracket.
Bracket, because closed circle. Okay. And then because they're two separate areas, we put this U, which means union. So we're putting the two areas together.
Union.
And then how do we write the second one in interval notation?
4.
4. And then what?
Infinity.
Comma infinity. And infinities always get parentheses. And what does the 4 get?
Parentheses.
Also parentheses, because open circle.
Open circle.
Okay? You guys are going to get sick of me saying infinities always get, because I will say it probably just about every
We
time.
wanna hear So that we can remember.
So you can remember it. That's right.
Again.
Repetition, right? Okay? And that's our answer.
Good job.
So notice we didn't really do anything different. We just did 2 of them, right? We had to do one and then do the other one. Okay? That's an or problem.
What?
It-
What
it's a-
problem?
It's a compound. It's an or inequality,
Oh, okay.
where we put two compound with 2 together
Carson.
with an or statement.
Oh,
It
problem.
just doesn't say it in the thing because on the question, right, it doesn't say or because.
Well, it actually does. It says it right here.
does on the, yeah,
Yep.
okay.
In between the two, it'll say
Yeah,
or.
Okay, got it.
So this, again, this is going to be an or problem.
Got
And-
it here, not.
And we just do, again, we do the same thing. We do one side and then we do the other. So let's start with this one on the left.
I say minus A.
Now there are two x's, so we want to get them together somehow. And remember, we want our x's to always be on the left-hand side. So we want to cancel this one out. How do we cancel that out? Subtract 5x. Okay, so subtract 5x to cancel that. So -3x plus 8 minus 7. Do we have to switch the sign?
Yes.
No.
What did we do?
Oh, no, we didn't.
We subtracted, right?
Divide and multiply.
We didn't divide or multiply. We subtracted. So no, we do not have to change the sign. Okay. Then next, what do we get rid of?
8
The 8. How do we do that?
minus 8.
Subtract 8. So -3x, -15. Do we have to switch the sign?
No.
No, because we subtracted again. So greater than or equal to. And then we've got one more step to get this x by itself. What do we do?
Divide by -3.
Divide by -3. So now we have x and we have a 5. And do we have to switch the sign?
Yes.
Yes.
Yes. Less than or equal to. And the reason for that is
Divide by.
we divided by a negative number on both sides of our inequality. So we're all done with that one. Or now we do the other one. So again, there are x's on both sides, and we want ours to be on the left. So we're going to cancel out
3.
the 3x. How do we cancel that out?
Minus 3.
-3.
So now we have 2x minus 3 and a 1. Do we have to switch the sign? No, because we subtracted. Okay, and now we're going to try and get that x by itself. What do we have to get rid of next?
Add 3 to the negative.
Add 3. So that cancels. Add 3 over here also. So 2x and 4. Do we have to switch the sign?
No.
No.
No, because we added. And then what else do we need to do to finish getting that x by itself?
Divide by 2.
Divide by 2. And we have x and 2. Do we have to switch the sign?
No.
No, because why?
The positive.
You divided by a positive. You only switch the sign if you divide by a negative or multiply by a negative. Okay, so we have our 2 statements here. And again, let's make sure this makes sense. So where should the 2 go in relation to the 5?
On the right.
So the 2 and the 5,
2 on the left.
2 on the left, 5 on the right. Okay. Always make sure you put them in the right spot, because otherwise your pictures get crazy.
Oh.
Does that make sense?
I didn't change my negative. I
Oh, you
changed
had a -2? Or a,
-5.
oh, -5.
Yeah.
Okay. Okay, so let's do this one first. It's right here. Let's do this one first. So this says, what sort of boundary point is going to go on the 5?
Close.
Close, right? And then what direction is it going to go? Yeah, it's going to go to the left. So I'm actually going to draw this up and over. It's going to go this way, right? Correct? And then what kind of boundary point goes on the 2?
Open circle.
Open circle. And what direction does that one go? To the right. Now, this is a little bit different. This is an or statement, right? Which means as long as one of them is true in any specific area, it's part of the solution. So if we think about this area over here, is this area over here going to be part of our solution?
No.
Well,
Is it-
yeah, because
because it's
Oh,
less
yeah,
than
yeah,
5,
yeah,
right?
yeah.
It's less than or equal to the 5. If I should have maybe used different colors, but this one right here keeps going this way, right? So yes, this area to the left of 2 is part of the solution. How about the area in between the 2 and the 5? Is that part of the solution?
Yes.
Yeah, it actually works for both of them. How about the area over here to the right of the 5?
Yes.
Yeah, because that one works for it's greater than 2. So in this case, our solution is actually everything,
the whole.
the whole number line. It doesn't matter what you put in, it will work for this one or this one. So if I put in like a 0, is 0 greater than 2? No. But is 0 less than 5?
Yes.
Yeah. So that's, if I put in a 3, is 3 less than 5?
Yes.
Yeah, I don't even have to check the other one, because as long as it's true for 1, and if I check something out here like a 10, is 10 less than 5? No, but is 10 greater than 2? Yeah. So it doesn't matter what number you choose, it will work for one of them. Even if I pick these boundaries, 2. Is 2 less than, or sorry, is 2 greater than 2?
No.
No, but is 2 less than 5?
Yeah.
Yeah. If we pick 5, we'll just say, is 5 greater than 2?
Yeah.
Yeah. So every point that you could ever pick is going to work for at least one of them. So our graph, I don't even like these, but our graph actually just goes forever in both directions. Okay. Now, how do you think we write the interval notation? This is a different, we haven't seen this one yet. If we go forever to the left, what do we write on the left?
Negative infinity.
Negative infinity. And if we go forever to the right, what do we write on the right?
Positive infinity.
Do we write on the right? Positive infinity. And infinities always get
Parentheses.
parentheses. This means everything from negative infinity to positive infinity. This would be your answer. This is the interval notation. This would be your graph. This is the interval notation. And then solve it, that's this part. This part right here is the solve part. So the solve part is the most work to get to that spot, and then we just have to graph what we get. Okay, so there are some unique situations where, a lot of times or statements, they just go out, and we've got the left side and the right side. But sometimes they'll crisscross like this, or sometimes you could have one that looked like this too. Let's say our boundary is here, and it goes this way, and the other one has a boundary right here, and it also goes this way.
The same.
They go the same direction. That could happen too. So would this be part of the solution?
Yeah.
Yeah, it works for both. Would this be part of the solution?
Yes.
Yeah, because it works for the purple one. Would this over here be part of the solution?
No.
No, because it doesn't work for either of them. So you can have these little weird things that happen once in a while, but most of those tend to be like that first one we did where they go opposite directions. Okay. Are we okay with that? Before we go on to the second type? The second type is an and statement. And statements are only true if both parts of the inequality are true. So going back to my example, if I tell you that after class I'm going to Sonic and going home, and then I decide afterwards, I'm just going to go home and I don't go to Sonic, is my statement true?
No.
No. Well, what if I go to Sonic and then, I don't know, I'm really tired, so I just sleep in the parking lot at Sonic. Is my statement true then?
No.
No. In order for the statement to be true, I have to go to Sonic and then I have to go home, right? Does that make sense? So in order for an and statement to be true, both of the inequality statements need to be true. Okay? That's for an and statement.
Oh, and
Okay? So you got the and then that means both of them are true. Are we good? To see our example? All right, now sometimes you see examples for and statements written like this. Sometimes they don't actually say and, they just say this. Now this is two separate inequalities. One of the inequalities says that -6 is less than -4x plus 2. Okay? The other part of this inequality says that -4x plus 2 is less than 2. So in order for this to be true, -4x plus 2 has to be both greater than the -6 and less than +2. Does that make sense?
yes.
You can only write statements that are written like this have to be and statements. You cannot write an or statement this way. So if you see it written like this, automatically and. Okay? Now, we've got a couple options here. One option that we have is we can actually split it up into those two statements. -6 is less than or equal to -4x plus 2, and -4x plus 2 is less than 2. Just like we did with the or statement, we can split it up into its two parts. Does that make sense? We just have to remember the whole thing here is greater than the -6, and the whole thing is less than the 2. Is everybody okay with how we split that up?
Yes.
Okay, so the -4x plus 2 has to be all together when you start. Now, at this point, we just start solving and get the x by itself, right? So what would you do first on this one over here on the left?
-2.
Okay. So that makes -8 and -4x. And do we have to switch the sign? No, because we subtracted, so less than or equal to. Then what? Okay. That gives us a 2, and that gives us an x. Do we have to switch the sign?
Yes.
Yes, very good. So it becomes greater than or equal to. And again, the reason for that is we divided by a negative on both sides. Now, here's our problem. We don't like the x to be on the left hand or on the right hand side, do we? So this says 2 is greater than or equal to x. If I write the x first, what does it need to say?
X is less than
Or equal to 2. Does that make sense? If you're going to switch the order, that's also going to switch the sign.
So we go back to the symbol that we had before.
Yeah, and not really because of that, but it's kind of separate. It's just that if you're going to say 2 is greater than or equal to x, but you want the x to be first, you have to say x is less than or equal to 2.
So
So
we
you
would
have-
have done it, start with the X, moving it to the other side.
And that's
we would've-
actually probably what I would have done is I would have added 4x to both sides, but you don't have to. You just have to, we just eventually want to get that x over on the left because it's just easier to work with that way. Okay, so this is done, and
So would it take it either way on the computer?
well, they're probably going to only look at the final answer anyway. So what they will probably have is x, and then you'll have to put in the sign and the 2 or something. The problems are all worded a little bit differently. So what do we have to do on this one?
Subtract 2?
Subtract 2. Cancel that out. Negative 4x. And this is a 0 now. Do we switch the sign?
No.
No, because we just subtracted. Then what?
Divide by negative.
Divide by negative 4.
Switch this
So x and 0 divided by negative 4 is still 0.
Switch this.
And we have to switch the sign because, again, we divided by a negative. Now, I want you to notice something here. Look at the steps we did over here compared to the steps that we did over here. What was the first step over here?
Subtracted 2.
What was the first step over here?
Subtracted 2.
What was the second step over here?
Divide by
Divide by negative 4, and here? Divide by negative 4. I'm going to show you in a minute. We can actually do this all at the same time if we want to,
Because you do the same thing.
because we do the same thing both times, right? So rather than doing twice, we can kind of do it just once. Okay, but let's go ahead and draw our answer here. Now the two boundaries are 0 and 2. 0 is on the left and 2 is on the right. So let's go ahead and do this one. We want x is less than or equal to 2. So what sort of boundary point goes on the 2?
Filled in.
Closed circle, yep.
Fill in.
Filled in.
Close cupcake.
I always say filled in. I say filled in. I say closed. I say them both. Technically, technically I should say closed all the time. And then what direction does this go from the 2?
Right.
Goes with less than. It's going to go to the
Left.
left. So I'm going to draw this like this, just to show that that one's going that direction. Okay, then I'm going to switch colors here. And I'm going to do this one in green. So this one is in green, and our boundary point is at 0. What type of circle is this one?
Open.
It's an open circle. And then what direction do we go from the 0? To the right. So this one goes this way. Now remember, for an AND statement, we need this to be true for both parts of the inequality. So if we look out here, is this area out here to the left of 0 true for both parts of the inequality?
No,
How do you know?
How do you know? Great question.
because it's not.
Is it true for the purple one?
Yes.
Yes. Is it true for the green one?
No.
No. So it's not true for both of them. Does that make sense?
Yeah.
For and, it has to have the purple and the green. That's why I used 2 different colors, so we could clarify that. Okay? So notice the green isn't out here. So it's not true for both. It's only true for the purple. How about in the middle? Is the middle true for the purple?
Mhm.
Is it true for the green?
Mhm.
Yes, so the middle is going to be part of our solution. If we go out here to the right of 2, is this one true for the purple?
No.
No, so we can stop there, because in order for it to be true for the and statement, it has to be true for both. So our solution here on this one is everything just in between the 0 and the 2.
So the answer is between 0 and 2.
Between 0 and 2. Now, how do we write that as interval notation? So again, here's our graph.
So, and statements we have to be true for both.
Yes. It has to work in both inequalities. So like if you put in a number over here like -5, yes, -5 is less than 2, but -5 is not greater than 0. And for an and statement, it has to be -5 is here and here, not just in one of them. So if we're going to do interval notation, this time is different. We've got 2 boundaries, right? What's our lower boundary?
0.
0. And what's our upper boundary?
2.
Okay. And what type of boundary symbol goes on the 0?
Parentheses.
Parentheses, because it's open. And what type of boundary symbol goes on the 2? Bracket. So no infinity this time because it doesn't go forever in any direction. just between 0 and 2, and that's all. Okay. Now,
It's
I-
a lot of steps.
I told you that I would show you this, and if it's confusing, just don't worry, just ignore it. But what we can do, let me make sure I copy it correctly. I was doing something the other day and I copied it wrong and that messed everything up. Okay. Our goal here is we can leave it as 3 parts to the inequality: the left, the middle, and the right. Our goal is to get the x by itself in the middle. Okay. So do you remember what we did? What did we start doing to start getting this x by itself? Subtract 2. The difference here is we're going to subtract 2 here,
And the two
here,
steps.
and here. So you're going to subtract 2 from all 3 parts. So notice that cancels. This would be -8.
Do you write it down?
If you want to. If you don't like it, then just don't worry about it. I'm just going to show it to you so that you've seen it. Okay, then what else did we do to get the x by itself? Divide by -4. And we divide everything by -4. That gives us a 2 and an x and a 0. Now, because we divided by a -4, what do we have to do with our signs?
Change it.
Switch them. So this becomes greater than or equal to and greater than. And when we write it like this, we don't like the big number to be on the left and the small number to be on the right. We like a number line, the small number on the left and the big number on the right. So we have to switch the whole thing. So this would be changed to 0, x, and 2. So what happens to our inequality signs?
They changed.
This part right here becomes that, right? And then this part right here becomes that. So when you're done, they should always be less than signs. Just have to worry about the or equal to parts. And if you notice, this actually visually makes more sense, because what does this say? X is between 0 and 2, right? And isn't that what we see? The solution area is between 0 and 2. So I actually, if I can do it this way, I like this way better, because you visually get that picture of, oh, it's between 0 and 2. And that's exactly where it is. It's between 0 and 2. Okay, but you can do it. You can break it up, or you can do it all at one time.
Break it up.
Break it up is better, because that's what I showed you first. If I'd have showed you the other one first,
No,
we like.
we used to do the equation like that. so-
Okay. Let's try this one.
Can I copy it?
Oh, that?
For a second?
Yeah, I'll leave that one.
Yes.
Yeah, I'll leave that alone. But that's not better. You told me that's not the better way.
Yeah, but in case I want it. In case I want it.
In case you want it.
I think I learned it like that.
Well, and depending on if they write it like that, it's really easy to do it that way. But sometimes they'll actually give you a statement that says this and this, and you can't put them together. So
You have to. put
until
it
the end, you could probably do it at the end. But now, what's the first thing you should probably always notice about these types of problems? There's a little word you always want to
Or
notice.
and.
The or. Is it an or problem or an and problem? And in this case,
And or.
it's or, right? Does that make sense? I hope somebody's up there.
When she's in class.
Is he? We need to go later.
Let me go see.
Okay. I'll let you do it then. I'll just stay here. I mean, I want you guys suddenly jumping up and destroying the room while I'm not supervising in here. So that's things I have to worry about with high schoolers. Not really. The kids I have are pretty good. They wouldn't jump up and destroy the room. Most of them would. Maybe a couple. But I'll wait for her till she gets back. So Sally, take all the time you need to copy that down.
I'm done.
Oh, you're done. Okay. Did you save them?
Yeah.
Let them in?
It was no.
They were out there probably freezing to death because it's so cold, right?
Yeah.
I mean, it's below 90. All right.
I needed to stand up either way.
Okay, so remember, we got two separate statements. We just solve each one individually. So what are we going to do with this one? This is a pretty short one, actually, right?
Add 6.
Add 6. So x, -7. Do we have to switch the sign?
No.
No. And so that one's done, right? X is already by itself. Or what do we do on the other one?
Divide by 6.
Divide by 6. So this says x and this says -10. And then do we have to switch the sign?
No.
No, so less than or equal to. All right, let's see if we can draw the picture here. I think this is another one of those that's kind of weird, but let's take a look. Our two boundaries are -7 and -10. Which one goes where?
-7 goes on the left.
No,
Oh, sorry.
because it's negative, right?
Okay, yeah.
So -10 here and like -7 here.
Yeah.
So let's do the -7. What type of circle?
Open.
Open circle. And then which direction does it go?
Left.
To the left. And then I'll use green for this one. So what type of circle goes on the -10?
Close.
Close. And then what direction?
To the
Left.
Also left. So what does that tell us? Remember, this is an or statement. So let's think about it. Is this part over here to the left going to be part of our solution?
Yes.
Yeah, because remember, it needs to work for at least one. So yes, this one works for both. How about in the middle? Will that be part of our solution?
Yes.
Yes, because it works for the purple. How about over here? Will this be part of our solution?
No.
No, because it does not work for either of them. So I'm going to use a different color here. Our solution is actually from here forever to the left. Okay, so actually this one right here is all we need to get that whole thing. Does that make sense? This one over here doesn't actually add anything to our solution.
I think the only thing that is confusing me a little bit is just the direction of.
How you know which direction?
Yeah.
And so that's where you want to make sure you remember less than and greater than. So less than is always to the left, as long as your x is first.
Okay.
That's why we always put the x first, because then the
Yeah.
arrows point, basically.
So-
Less than goes to the left, less than goes to the left.
Okay, less.
Their
Okay.
pointed way is on the left, so I put
Yeah.
arrow on.
Now, how would we do this in interval notation? If it starts here and goes this way, -7, and is that the upper boundary or lower boundary?
Lower.
Upper, yep. Oh, sorry. It's the one on the right. She pointed. That's what I was looking at. And then what goes on the left then if it goes forever to the left?
Infinity, negative.
Negative infinity.
Draw contract.
Okay. And then infinities always get
You're welcome.
Parentheses.
parentheses. And the -7 gets what?
Parentheses.
Right.
Parentheses. Because of the 7 is open, right? Now, if the 10 was the boundary, then we'd have close. But the 10 didn't actually add anything, so we don't have to worry about it.
So
Okay. So that's why I say sometimes these, depending on the direction, because they can go any direction they want to. So we've got to just look at, is it an or statement or an and statement, and which area is going to work for both or one or the other.
So if it is like any statement, we don't need to write two points, right? Just only
If it's
one.
an and statement, you'll never
Just
write
one.
two sections. It'll
Just
always
one.
be just one. If it's an or statement, it could be
Two.
just one, but it also
Right.
could be two, because it could be separated. But and you'll never need that union symbol for and, because it has to work for both. Okay, are we okay to go on from this one?
I think so.
All right. And it's even already in the green circle, but what's important about this?
It's an and.
It's an and
And,
statement. Can I erase this one now?
Yes.
Okay.
Thank you.
And since it is an and statement, and it's written separately, we can't like put it back together. We just have to solve each one individually like we did before. I'm going to keep my colors for the graphs. So actually, no, I'm going to keep purple for the graphs. So let's keep working with our purple here. What do I have to do first?
Subtract 10.
Subtract 10. That's a good choice. -5b and 20. And then because we're subtracting, do we have to switch the sign?
No.
No.
No, subtracting doesn't switch the sign. Then what do we have to do?
Divide by negative five.
Divide by -5. So now we have a b and a -4. Do we have to switch the sign there?
Yes.
Yes, it becomes less than, and because why?
Divided by negative.
We
five.
divided by a negative. It has nothing to do with what the answer becomes. It's all because we divided by a negative. And I try to emphasize that because every year I have people make that mistake because they know they're supposed to switch it sometime, but they forget.
That's gonna be me.
It's going to be you?
Yeah.
Okay. And so we're done with the left side, and let's go with the right side. What do we do first for this one?
-2.
Subtract 2. So this is 7b, and this is -42. And then do we have to switch the sign?
No.
No, because we did not divide or multiply, so less than. Then what else do we do?
Divide by 7.
Divide by 7. Oops, 7. And we get b, and we get -6. Do we have to switch the sign?
No,
No, because why?
because it was a positive.
You divided by a positive, not a negative. So this stays as a less than. All right, let's see if we can draw this picture. Where should our numbers go for our boundaries?
-6 go first and then
Yep, -6 goes first and then -4. And again, I don't care if it's to scale. I just want to see the boundaries. In the computer, they might have the numbers already there for you. But when you're drawing them for me, like on a test, I don't need to see like every number between 0 and whatever. Just write down the boundaries. So let's start with this one. B is less than -4. So what sort of a boundary point goes on the -4?
Open.
Open. And then what direction should we go from the -4? Left, because it is less than. Okay, everybody okay with that?
Mhm.
Okay, then we'll go to the other one. What sort of a boundary point goes on the -6?
Open.
Open, because it's less than. And then what direction?
Left.
Also to the, so this one looks like the last one, doesn't it?
Mhm.
Now here's the difference. It is an and statement.
One.
So in other words, for it to be part of our solution, it has to work for both parts of the inequality. So is this section over here on the left going to work?
Yeah.
Yeah, because it works for purple and for green.
Yeah.
Is the part in the middle going to work?
Yeah.
No.
No. Not for
No.
green.
Oh, no.
We've got people disagreeing. Let's have a fight. No, I'm just kidding. Why does it not work?
It doesn't work.
It doesn't work for green. Okay, and then is the part over here on the right going to work?
No.
No, it doesn't work for either. So the only section that works this time is, let me get my black marker here, is only from the -6
Negative.
to the left.
To the left.
Does that make sense?
Mhm.
Yes.
So when we write that with our interval notation,
-6.
where does the -6 go?
Right.
It's over here. And then what goes over here?
Negative
It's,
infinity.
yeah, it's going forever to the left. And then
Then
infinities always
parentheses.
get,
Parentheses.
and this one gets parentheses also because it is open.
Okay.
Does it make sense, the difference between those two, the and the or? That's why I try to draw the colors so you can see, oh, here, both green and purple.
And
don't
should
they-
be right.
Don't they have to be both of them through to be able to be in?
Yes. So that's why, whoops, sorry. Sorry, on the other side of that wall there. So that's why when we see both the green and the purple, we know that's part of the solution. Here in the middle, we only see purple for an and. That's not going to be part of the solution because
Oh,
it
so-
needs both.
So the solution has to have the two.
The solution has to have both for an and.
Okay.
For an or, it only needs one of them.
Okay.
And that's the difference. Okay, just like if you said you're going to do this and this,
Uh-huh.
in order for that statement to be true, you have to do both of them. So that's what we have to have. If I need this and this, it has to work for both the blue and the green.
Okay.
Okay.
Which is the -6 and infinity because it
Yep.
works on both of them. Okay.
Yep.
Okay.
Okay. Does that make sense?
-8.
I really love it when people give me looks like that and they get like 100% on their test. It's like, oh yeah, okay, whatever. Okay. Okay. Now this one does not say and it does not say or. What is it?
And
How do we know?
And. That is and.
How do we know?
because there's
3
like
of them.
only and can be written like this, where you've
Yeah.
got a lower and an upper and then stuff in the middle, right? So this is actually an and statement. It has to be bigger than -4 and it has to be less than 11. Both. Okay, does that make sense?
Mhm.
So let's try to solve this one all at once. Sorry, Sally. Let's try and solve this one all at once.
I already
So-
try with
We're trying, you already split it up?
No.
We're trying to get that m by itself. What would we do first?
-8.
Subtract the 8. Is everybody okay with that? Subtract 8 from all three parts?
No.
No?
Are you gonna use the,
it's all confusing.
can we do the?
You want to split it up?
Yes.
Okay.
Please.
All right, let's split it up. Here I thought we were going to make,
No,
this so easy.
sorry.
Okay. So if we're going to split it up then, what do I have to write down?
-2
Equation.
-4.
is less than.
Yep.
8 minus 3m.
Okay. And then what?
And -3m.
We need the 8 too. 8 minus 3m, because that's all together in the middle. That middle has to go with both,
Oh,
and then less than or equal to 11. Does that make sense? It's everything in between these two inequality signs stays together. Okay. All right, so now let's do our work. What do we have to do on the first one here? Subtract 8. So -12, -3m. Do we have to switch the sign? When we subtract, do we have to switch the sign? No. Subtracting doesn't switch anything. Then what?
less than 3m.
Divide by, be careful, divide by what?
3.
-3.
Oh, yeah.
So we get a 4, we get an m. Do we have to switch the sign?
Yes.
Yes, because why?
Divided by
We
negative.
divided by a negative. Very good. You might be my first class ever that everybody's going to get that right. We're going to keep pounding on it until we all remember it. Okay, so this becomes greater than, but remember we don't like it written like this, do we? So what are we going to write?
M is less than 4.
M is less than 4. Correct. And then we're going to go to the other one and we're going to do the same steps, right? So what will we do first? Subtract 8.
Sorry, I'm still trying to write down the.
Oh, sorry. I'll stop here for a second. Oh, and I just gave that away. We don't switch the sign when we subtract 8. So now I'll pause for writing time.
I think I do a test. It's really confusing.
Okay, are we good to go on?
Yeah.
Okay, what else do we want to do?
Divided by -3.
Yeah, divide by -3.
Flip it.
So this is an M, this is a -1, and do we have to switch the signs?
Yes.
Yes.
Yes, because once again, we did divide by a -3. So this is the reason we have to switch the signs. You don't have to circle it in red when you do that. I just am trying to emphasize this is why we're switching the signs. So let's see what we can do with this. Our two boundaries are,
-1 and 4.
-1 and 4.
and that's pretty obvious, the -1 goes on the left and the 4 goes on the right, correct? So let's start with this one. M is less than 4. So what sort of boundary point goes on the 4?
Open.
Open
Open,
that.
and then it goes to the left. Okay, so it's covering these two areas on the left and the middle, right? I mean, correct? Then what sort of boundary point goes on the -1?
Close, right?
Closed, and it's going to go which direction?
Right.
To the right.
So between
Okay.
-1.
Now remember, this is an and statement.
So we just need 1.
So it has to work for both inequalities. Does over here on the left work for both inequalities?
No.
No, just the purple one. Does the middle work for both inequalities?
Yes.
Yes, purple and green. Does the over here on the right work for both inequalities?
No.
No, only the green. So our solution is,
-1.
got too many markers in my hand.
-1.
from -1 up to the 4. That's our solution. Okay, so if we're going to write this in interval notation, we've got two boundaries this time, right? So it's going to be -1 to 4.
Mhm.
What does the -1 get?
Bracket.
Bracket, because it's a closed circle, and then the 4 gets parentheses.
parentheses. Oh, it's harder and harder. It's drama.
Yeah.
You
Well,
must
what
say
if I
like
just made
drama.
it easier and easier? That wouldn't make any sense. If I started with the really hard stuff and then said, okay, now let's go back to the easy stuff. That wouldn't make any sense, would it?
You know what would be perfect?
All
is
this
if we
still
just-
God.
You showed us one and then we did one the whole,
I know. And honestly,
so many examples of the one.
here's the downside. I mean, you guys only have to come one time, but that one time is 3 hours long. And so we have to cover all this
Yeah.
stuff. Because, I mean, it would, if we only met like 40 minutes, like several times a week, we could do the same thing. And it would be one thing at a time. And so,
Let's do
Right.
like that.
yeah, you got to talk to Drury about that one. So, does that make sense for this example?
Yes, sir.
Okay. And there you go. Now, again, this was 3-1 and 3-2 are together. 3-1, remember, was just one inequality at a time. 3-2 is when we put a second one in there, and then we have 2 to work with at one time.